Now, after the theoretical section in part 1 of this tutorial, let's build our Agentic Bug Hunter AI. We'll start by setting up our project structure and implementing each function we discussed. Then wire them up together into a Agentic loop. First, we have to install UV. It is a modern Python package installer that's significantly faster than pip and manages dependencies and virtual environments for Python projects. Also, I'm using Ollama because it lets me run LLMs locally. It exposes an OpenAI-compatible API, so our code works with local models without changes. We'll use it to run models like Queen on our machine. And the first thing that I will do is creating the functions folder. And of course, the function or just fn.py. Next, I will create the env file with the following content, but not here. What we have here is the LM model name for Ollama, Queen. After that we have the working directory, converter. This is where the LM is going to work. Max chars are the maximum characters for reading from a file, because we are going to read files and fix bugs there. Max retrace are maximum API retrace attempts. Open API base URL. This is the Ollama API endpoint URL. And the OpenAI API key is the API key that we are using. Next step is to import the necessary packages in our function file. We have import JSON. This is for JSON parsing and serialization. OS, the operating system package for OS operations like paths, environments, and etc. Regular expression for pattern matching. We need the system-specific parameters from sys package, time utilities package for timing functions and features, subprocesses. We need this to run external processes, and .env that loads variables from the env file with that function. Next, we need to write our first function called getFilesInfo. That will list files and directories in the specified path, returning each item's name, size, and whether it's a directory, with a security check to ensure the path stays within the working directory. So let's explain how this function works. The function takes working directory as a required parameter and an optional directory parameter that should be none. If directory is not provided, it's none or is an empty string. We default it to the current directory within the working directory. On the next line, we convert working directory to an absolute path. Default parameter handles omitted arguments. This line handles explicit none or empty values from the LLM. Python's OR uses short-circuit evaluation. If directory is truthy, it returns the directory. If it's falsy, it returns the current directory within the working directory. OS path join joins the working directory path with the directory parameter into a single path, and OS path apps path converts that join path to an absolute path. Next line, we are doing security check that ensures the target directory is within the working directory to prevent path traversal. Then we create the variable final response that initializes an empty string to collect the output. OS-listDir function lists all items, files, and directories in the target directory. And we iterate with the for loop over contents. We build the full path to each item and check if the item is a directory. After that, we get file or directory size in bytes. In the final response, we append the formatted info to the response string and return the complete listing. Next function, getFileContent. Let's explain the function how it works. The function takes two variables, working directory and file path. First, we convert the working directory to an absolute path. Then we join it with the file path and convert it that an absolute path as well. Next, we perform a security check. If the file path doesn't start with the working directory, we return an error to prevent path traversal attacks. We also verify that the path actually points to a file, not a directory. If it's not a file, we return an error. Then we try to open and read the file. We read up the maximum number of characters specified in our maxchars environment variable. If the file is longer than that limit, we truncate it and append a message indicating where it was cut off. If any error occurs during reading, we catch and return an error message. Otherwise, we return file content.